Page 2 of practice exam 3 starts off with provide the missing ingredients for the following aldol transformations. Also name the kind of transformation. All right, so in this molecule we have, or in this product rather, we have a beta hydroxy ketone. All right, this is the alpha position in purple, and in orange that is the beta position. So there's a hydroxy group at the beta position, beta hydroxy ketone. All right, and this is indicative of an aldol addition reaction. So that's the name of the transformation. All right, now we have formed this bond in this reaction, right? The bond that I've drawn the line through. Okay, and this came from an enolate with this carbon being nucleophilic. All right, so that means that we deprotonated at the less substituted carbon, the methyl group, rather than this CH2 or methylene. Okay, so we formed the kinetic enolate in order to form the product provided. All right, in order to provide or to generate a kinetic enolate, your base of choice for aldol chemistry should be LDA. All right, and the other thing that we need to know is that our nucleophile is always going to attack a carbonyl, right? It either is going to be a ketone or an aldehyde, and you just look at what is attached to this orange carbon, right? So that is attached to a phenyl group and a hydrogen, right? And that's exactly what our carbonyl electrophile will be attached to. And so our second reagent here is going to be benzaldehyde, right? Because again, our electrophile highlighted in orange there is attached to what? A phenyl group and a hydrogen, just like that one. All right? All right, so the next reaction, so this is under acidic conditions, which you should be comfortable with aldol reactions happening. All right, now remember, acidic aldol reactions cannot stop at the beta hydroxy ketone. All right, and instead, it's going to give us an alpha beta unsaturated carbonyl. Okay, and so the bond that we're forming there is going to be that alkene that was due to an elimination of an OH group after it had been protonated to give water, which you see here. Okay, so the formation of water is a hint that this was a condensation reaction, right? And so when you do the retrosynthesis here, this is going to be just a dimerization of this unsaturated ketone. So this unsaturated ketone is not alpha beta unsaturated, right? This is alpha position, this is beta, okay, and this is gamma. All right, so this is a beta gamma unsaturated ketone. All right, so under these conditions, we would form an enol that would make this carbon nucleophilic, okay, and then another equivalent of this ketone would be protonated under acidic conditions, activating that as a good electrophile for your weakly nucleophilic enol. Okay? The last two questions on page 2. The first, every Robinson annulation involves which two enol or enolate involving reactions? The first step is a Michael addition, okay? And the second step is an aldol condensation reaction, all right? So remember, aldol condensation reactions always give you alpha beta unsaturated ketones, or at least carbonyls, alpha beta unsaturated carbonyls. It could be an aldehyde. In the case of Robinson annulation reactions, you always end up with a cyclohexenone, okay? And so remember, just like an aldol condensation reaction, you know that the double bond that's formed, the alpha beta unsaturated bond, all right, that's going to come from an aldehyde or a ketone, all right? So we know that this bond is breaking, all right? So if we break that bond and we put an aldehyde in the correct place, what we end up with is something that looks like that. All right, so this carbon was nucleophilic in the aldol condensation reaction, and it attacked this carbon to do the aldol addition, which kept on going to give the condensation reaction. All right. So we also know that the product drawn here in purple had to come from a Michael addition. All right, and so a Michael addition always comes from an enolate attacking the beta position of an alpha beta unsaturated carbonyl. Okay, and so this is the bond that's forming. Again, here in blue, this is the would-be nucleophilic carbon. Okay, which means that there should be a double bond here. All right, and so if we work backwards again, this is going to give us something that looks like this. All right, so that's our alpha beta unsaturated ketone, all right, and the other partner is just acetone. Okay. Now, remember, acetone is not something that I would have you classify as a Michael donor. Okay, it doesn't have the 1,3-dicarbonyl species. However, this question told you that this is a Robinson annulation. So you know, or you should know, that a Robinson annulation reaction involves a Michael reaction followed by the aldol condensation. All right, so again, the conjugate addition via the acetone enolate would be a minor product, right? Because it's not a Michael donor, right? But you're given the information here that a Robinson annulation question is happening, all right? Robinson annulation is not going to be a huge point of emphasis on your actual exam. I just put it on here because it's a very challenging question that makes you think about both Michael reactions and aldol condensation reactions together.